All right, so here we're supposed to use the table given, and the figure contains a scatter plot and regression line for each data set, where X represents years since 1980 and Y represents enrollment in millions. Interpret the slope of each model, and I didn't give you that because what I want to do is I want to go about how to do this by hand and on Excel as well. Then we're supposed to use a regression model to predict the male and female undergraduate enrollments, and then use the models to estimate the first year in which female undergraduate enrollment will exceed male undergraduate enrollment by at least 3 million. All right, so first off, we need to find our linear models for both of these. So let's do it two ways. Let's do it calculator way first. And again, because there's so much data, I've already typed that in. And so what we need to do is we need to do a linear regression. So we'll do 4. And it looks like I've done some other calculations since the last video. So L1 and L2, let's put that in 1. Okay. And so that's my equation for the first one. Now, let's do it again and do 4. Now we want to do L3, so we go Shift L3, and let's put that into vars, and let's put it into a 2. So now those are two equations, and if we graph them, that's what they look like. Okay, so that's going to be our key thing. We have those two graphs. It's a scatter plot, so we have the actual data points plus the linear regression model. And so we have both of those. And so now let's do it a different way. Let's do it using Excel. Now with Excel, again, I've done typed it in. And remember, we have to do it since 1980, so I converted it to the 0 through 34 because that's how it needs to be done. And what we're going to do is we're going to highlight all the data. It's going to take the first column as X, then the next columns as the Y values. And we're going to say insert. We're going to choose a scatter plot, and I'm going to choose just the plain scatter plot. And after that, what we need to do uh, uh, is to add the trend line and actually come up with the equation. So to add a trend line, we right click on one of the dots, and I'm doing the orange ones first, which is the female, it looks like. We're going to add a trend line. Then when we go over here, we make sure it's linear, which it is. And then we're going to say, let's display the equation and our R squared value. So that's what we have here. Now we're going to display, add a trend line here. And we're going to make sure it was linear again, and we display our equations here. So that's what we get when we do those two things. And if we remember, the other ones was 0.14 and 0.08, and then the 5.2 and the 4.69 for the B's and stuff like that. And so those are how we can get trend lines, graphs, things like that if they ask for it in the problem. Now, the next part is supposed to be we're supposed to come up with what do the slopes mean. Well, while we have it open, let's look at the slopes. Here we have 0.0872. Now, what we need to do is remember that was in millions of students. We need to take that number times a million. And if we do that, and we round, it probably says to round to a certain thing. So let's go back to our equation that says to round to maybe millions. And so let's just take it to the millions. And so that was 0.0087. So that was going to give us for A, it's going to give us 87000 students per year for the males. That's going to be the 87,000 students per year, and that's going to be the male student enrollment is increasing by that much. Now, the female was the 0.14, so that's going to be instead, it's going to be 1, 4, and then 1, 2, 3, 4 female students, but we'll just say students again, and then we'll say female here. And that's how much it's increasing per year. Okay. Now B says we're supposed to use the remodel to figure out when 2025 is. All right, so 2025 is how many years past that? Well, 80 to 2000 is 20 plus another 25, so that's going to be 45. So we want to know for this, we want to know the males at 45 and the females at 45. So what we can do is we can go back to our calculator. That's probably going to be the easiest one. And we can do second trace of value. We want 45, and it's on the chart, so we're good here. And so that's going to give us for males, that's going to be the 8.6 million. Now, a nice thing about this is since we're already on this graph, if we arrow up, that gives us 11.5 million for females. So that's a nice thing. Once you're on a graph, you don't have to keep typing it in. You can just move up and down on it. And so going back to our table over here, that one said we had males was going to be 8.6 million, and this is going to be 11.5 million. All right. So now use the regression models to estimate the first year in which female undergraduates enrollment's going to exceed that. Well, if I look here, that is like 2.9 million, right? Okay. So 2.9 million there. So probably if I go up one, it's going to be into the next one. And so if we say instead second trace 1 and we say 46, we get 8.7 and we get 11.7. And so that's going to be 3 million. And so that's going to be at the point where they're going to be, this is going to be 3 million more than this one. Now, that's again with rounding. That's 6, 8, that's 6, 8, and then it's got a 9 here and an 8 here. So it's not exact, but it's going to be in that year. It's going to be that. So what we can say is, the first year will be for part C. Let's see, C. It's going to be 46 years after that. So in 2026 will be first time exceeds by at least 3 million. Okay. And so that would be what we get on that problem. All right. So hopefully that helps you on that one. And now let's stop there and come back for another one.